Hey guys, we are back again to give you guys another update for the Stair Climbing Robot project, and today we will tell you some problems and that we found during the project. And here's George, he will explain to you what is the problem. And I think we will start with the gears.
The gears is actually the main problem in this project, because the gears play the most important role in this project to move the wheels, the leg, the center mass. Everything that need to move is controlled by gears. But we found that one, the material make it break so easily, and two, the error caused by the printer that make them, they can't fit together very well. So when they're trying to move on the ground, it will actually
Slip.
yeah, all the time actually. And as we can show you, like as you can see that yeah, here you can see here the wheel is not trying to move. The gears in here is not fit together, and even we trying to hold them even tighter, they're just not working because the material make it worn out so fast, and the arrow caused it even worse. So maybe we need to change the material into steel or something more stronger. That I think that will solve the problem.
So basically what we found out is the wheel didn't want to rotate because of the gears didn't bite each other very well. Yeah, there's a lot of error with the 3D printer. The size is not perfectly the same as the one that we draw in the 3D modeling software, and I think that is our main problem. This problem will be solved if we use steel as the material for the gears. We are pretty sure of that.
Yeah.
But there's one problem, since making the gears out of steel will cost us some money and development time. I mean, I think it will take about 1 month to make the steel gears.
Yeah.
And I don't think it will be cheap to manufacture it.
Yes.
Since we are doing it only for a small amount of quantity.
Yeah.
And the other thing that we found is a bit this here. As you can see, this is the fan that we use to cool down the IC, the chip for the motor shield. This chip is currently pretty warm, and it can go up to pretty hot when we use the robot constantly. And
Yeah.
for it, we are trying to find a heatsink, and maybe we'll try to order online if we cannot find it locally.
Yes.
But just now the robot has just shut down prematurely because I think the chip is getting too hot, and it decided to shut down itself to prevent further damage.
Yes. Actually, in the mode 1 and mode 3, that which the wheel is trying to move forward and backward, like this. We're trying to move forward and backward, but there's one thing that when motor trying to move a side to another side to counter the directions, it causes a lot of current. And after we test several times, we found that when the motor need to change the rotate direction, it took 2A for the currents.
2 amps.
Yeah, and that's almost enough to break the chip.
Yes, we think that a lot of current is also one of the main reasons why the robot start to fail suddenly.
The motor shield should the motor shield can take 4 amp actually, but since we don't have the cool down device,
Yep, it will be getting pretty hot, starting from 2 amps.
Yeah, so as we need to balance it, it will get a lot of currents because it need to change the direction very often. So yeah, we need to find out the cool down device.
Yep. So I think there's the main problem for our project. The first one is being the gears worn out too easily, and the other problem is the chip getting too hot to operate. And is there anything else?
I think there is another one that as you can see that we attach everything on the hardware right now.
Yep.
And the hardware is become very heavy than before. It's very heavy. That means that we need to add more weight on the center mass, and the same again, the gears can hold the weight.
Yep.
Yeah.
Since the robot is getting heavier and heavier,
Yes.
we don't think that the plastic gears that are printed by the 3D printer can overcome those weight, and we think that they will just break suddenly.
Yeah.
When we test it and test it again.
We actually tested once that we did a lot of weight. As you can see in here, right now the center mass is not enough to make the robot turn its leg. We need to attach about
More weights.
Yeah.
About
2 times of this.
yep, about 300 or 400 grams, we think.
Yes, and it will become much heavier. And we test for once in the last day, but sadly we didn't take the video for that. It make a pretty good turn. It turns its leg on the stairs, but the gear just worn out.
Yep.
Yeah, after
It will work if we print out another gear, but it will just work for only a couple of times before it started to broke.
Not even a couple of times, I guess.
Only once.
Yeah, only once.
Yeah, so
Sometimes when we print the new gears and replace it, and we attach the heavy thing on it, the gear just worn out immediately. The
Yep.
robot don't even move.
we didn't do any work on the robot, and the
Just
gear
attach
just
it and it just break.
give up.
Yeah, it just break immediately, and this make us, yeah.
So we are pretty sad by the truth, but we'll think of another way maybe,
Yeah.
and we hope we can solve this problem soon,
Yes.
because I think that's the only problem that prevents us to go further from here.
Yeah.
Yes, yes.
I think that everything, the problem is actually stuck us in the real test. But if we just don't let the robot touch on the ground, that everything is work really well.
Yep. Guys, here we have lifted the robot onto the ground, so there is no weight that is forcing it down. It is held by these boxes. And should we start?
Yes. When we put the robot on the ground, the four wheels should take the whole weight of the robot. And since it doesn't have some friction on it, you will always
Slip.
Yeah, slip. You can move. You can only move forward and backward, but when you need to turn, the robot just too heavy. And as you can see, a lot of wires in here.
Yep.
Is just stop
Just
him
adding
from-
some weight to the robot.
Yeah. Actually, this wire could took the whole thing down. You can see that right now, and yeah, we should replace it with some power source. Okay, we just show you the ideal situations, and now when we should restart it. Okay, now the robot is restart, and his is in the first mode, the rest mode. So as I close the pulse, the robot still do nothing because it's in the resting mode. And now we choose the
Walking mode.
yeah. So now
Traveling mode.
traveling mode. And now, oh,
so we'll run the traveling mode.
yeah, and so you can see that the robot will try to follow up where the accelerometer is tipping to. So take a look at the wheel. Now I want to let the robot turn to the left hand side. So
Yes.
as you can see, I took it in the wrong direction, but as you can see, when you're trying to turn, the two wheels is rotating to the different
Direction.
directions, so it will make the turn. Yeah, and like this, and forward, backward. Yeah. Yeah, I'm sorry, I took the accelerometer in the wrong direction.
No problem.
In the turn side, yeah. And now is the second mode, the stair climbing mode, and so when I stop the pose, it don't do anything. That's normal. Yeah. When we wanted to climb up a stair, we push this button again. So now he extend and rotate the arm and climb out a stair. We just let everything back to where it started. So that's basically how it works, and we can do it again by push the button again. So we'll do the task. Oh, it has some delay in the right
Hand side. Yep.
Yeah. So okay, and now the third mode is to balance, and it just basically the traveling mode, but this time we put the chip on the robot. So when the robot is falling forward, then the robot move forward to catch up the body, and it's the same when it's falling backward, the robot will try to catch up. So that's how it keep balance. And yeah, so it's basically just the traveling mode, but in the real we will put it on the robot. Just let the robot do the whole thing. Yeah. So that's the idea for that. Okay.
I think that's all for today's video, guys.
Yeah.
If you have any suggestion, as usual, you can leave it down in the comment sections below. And thank you for your time. We'll see you guys in the next update.